Today we're going to work on solving simpler problems for a problem-solving strategy. So to start with, we're going to look at an example. It looks like the figure to the right is made up of 25 little squares, but Gina thinks that there are more squares than that. We're going to try to solve a simpler problem to find out how many squares of any size are in this figure. Now, this looks like this one is a 5 by 5, but we're going to try to figure out what is a pattern that we can get no matter what the size. Okay, we can take a look at a 1 by 1, and we know that there is one 1 by 1 in it, correct? Okay, suppose we have a 2 by 2. And in the 1 by 1, there's only one size that we can look at. Okay, in a 2 by 2, how many of the little squares do we have? All right, we have 4 of the 1 by 1s. And then what else do you notice? You do have one big one, correct, one of a 2 by 2. Is that it? Okay, so I'll have a total then of 5 altogether. Okay, and the next one we're going to do, let's do a 3 by 3. See if we see any patterns. Here I just had a total of 1. Here I have a total of 5. Okay, and this one's a 3 by 3. How many little 1 by 1 grids do we have? Right, we have 9. How many extra grids do we have? Well, the other size looks like it'd be 2 by 2s. How many 2 by 2s? Here's 1. Okay, here's 1. Another one. Kind of looking at the corners. Okay, looks like we have 4 of them. Okay, are there any other squares? Right, we have one more, and that is the 3 by 3. Okay, so it looks like you had 9 little ones and 5 other ones for a total of 14 squares. Okay, are we noticing any patterns here? I think we can set up a table or chart to help us out. Okay, well, the 1 by 1, or there was just one little square in it, had a total of how many? 1. Okay, these are the little squares. And this was the total other. This is the total. Okay, this one, we had how many little squares? Okay, 4. How many do we have all total? 5. Okay, this one, how many little squares? 9, but we had a total of 14. Do you notice, are we going up by a certain amount every time? Well, it looks like we went up 4 here. Here we're going to go up 9. Anything special about a 4 or a 9? Oh yeah, the 4s match here. Okay, the next one's going to be a size 4, a 4. Oh, this one's going to have 9 little ones. How many little ones do you think a 4 by 4 is going to have? 16. Do you think we're going to add 16 to this number? Okay, let's try it. If we have a 4 by 4, how many little ones? We're going to have 16 little ones. Then how many by 2s? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, 9 2 by 2s. What about 3 by 3s? Okay, can you see we're going to have 4 of them? And then 1 4 by 4. For a total of how many? Well, 16 plus 4 is 20, plus 10 more gives you 30. Now, is 14 plus 16 30? Okay, what do you think we're going to add to get this next one? I think you're right, 25. You can also notice that 4, 9, 16, and 25 are what we call perfect squares. A 2 by 2 is 4. A 3 by 3 is 9. A 4 by 4 is 16. A 5 by 5 is 25. So we're going to take 30 plus 25 to get how many? 55. So we have found out that the total number of squares we think here will be 55 squares. And we can kind of count them. I would have 25 to start with, 1 by 1s, 2 by 2s, 10, 11, 12, 13, 14, 15, I think 16 of them. 3 by 3s, 9, and you see that kind of the pattern continues here. 4 by 4s, 4, and 1 5 by 5. And if you add all that together, you're going to get 55 squares total. So this is an example of where we can use a simpler problem and finding a pattern to help us solve a problem that looks kind of overwhelming to start with.